Okay, so question number 5. Is carbon disulfide polar or nonpolar? So first let's draw out its Lewis structure. And first we're just going to find the total number of valence electrons for this molecule. Carbon has 4 electrons. Sulfur has 6. And we have 2 sulfur atoms, so we multiply that by 2. And we end up with 16 valence electrons. So now carbon will be our central atom. And then I'm just going to draw 2 single bonds to my sulfur. And notice that carbon doesn't have a full octet yet, so let's just make these double bonds. And if we look at how many electrons I've drawn so far, each bond contains 2 bonding electrons. So we have 8, and I need 16 in total, so for the remaining 8, I'm just going to place them on my sulfur atoms. Okay, so now we're left with the following Lewis structure. And if we analyze this, carbon has 0 lone pairs and 2 bonded atoms. So using our Vesper table, we can find out its molecular shape, which is linear. And also its electron geometry is linear as well. So there is some electronegativity difference between carbon and sulfur, but even then, because of its symmetrical shape, these electronegativity difference would cancel each other out. So therefore, this is a nonpolar molecule. Okay, so the junior tutor said covalent bonds become polar because of the electronegativity difference between the elements involved. So they talk about electronegativity, how you can calculate the dipole moment. And it's actually noted that carbon and sulfur have the same electronegativity. So their bond is actually nonpolar. And when you have a molecule that's made up of all nonpolar bonds, then the entire molecule will just be nonpolar. So this solution is correct. I'm also going to add that CS2 is linear and symmetrical, which also indicates a nonpolar molecule.